Hey Channel 9ers out there, we're back with another video on the Visual Studio 2010 and .NET Framework 4 week. Here we are chatting with Daniel, a familiar face here on Channel 9. Daniel, why don't you reintroduce yourself for anybody out there who doesn't know you and tell us a little bit about what you're showing us here.
Sure. So hello everybody, hello Niners out there. My name is Daniel Moth. I've done a few screencasts on Channel 9 in the past, and it's my great pleasure to be here to do another screencast on the debugging enhancements for the parallel programming models. And in particular, what I'm going to show today is how we have made tasks a first-class citizen in the debugging experience.
Ah, very cool. So let's go ahead and dive right into this.
Yeah, let's do it.
Yeah.
Okay, so here we have Visual Studio 2010, and I have a single code file in here that I've named P. And the important thing today is not the actual code, it's the windows, the tool windows we're going to use to actually explore the code. So what am I doing here in the entry point? I'll just show you that. Well, I'm starting a task, so I'm starting 4 of them in particular. And what you can see is that they all start their life in the method M, and I'm also passing in some states, 6, 7, 8, 9. And our goal is to find where they go after M. What kind of code path does each one of those 4 tasks follow without looking at the code? The way we're going to do that is by hitting 4 breakpoints, and then we're going to stop and hit the 4 breakpoints again, using the new features this time to see how much easier it is to explore the code. So let's go and have a look at how that works. So I'm hitting a 5 here, and I'm hitting the first breakpoint. So I started 4 tasks. So how many tasks have I got running right now? Well, you can't really answer that question. However, if you have a bit of inside information that I do, and I have done this before, I can see here I'm running on a quad-core machine. I started 4 tasks, so logic tells me 4 of them are running. And tasks get executed by threads, so actually I can go in the threads window and have a look. Now again, in the threads window, far too many entries, I have to find which ones map to the tasks that I executed, not other threads that someone else or my code elsewhere is running. So again, because I have done this before, I know that these tasks down here, these threads down here are actually executing tasks. And I can go here and obviously double click and the usual stuff happens. The context of the IDE changes, the locals window updates. I can see in the call stack window, we started life in M and then went to the method O. If I go do this for the other thread, again it went from M to O. For the other thread that runs the tasks, M to O. And for the last one, it's the same story. So first I had the inside knowledge to find my tasks. And second, in order to see where they went, I had to do a whole bunch of double clicking, or at least hovering over if I wanted to use the new Visual Studio 2008 feature. Okay, that's what we did at the first breakpoint. Store that and let's go to the second one. So on the second one, I want to see what code paths they have followed now. And I can see that one task went from MO to IC. Then the other one went from MO to TH. Again from MO to TH. And finally the fourth one, MO to TH. So 3 of them went one way, the other went the other way, but for me to discover that information, I had to go and do some double clicks and use 2 windows, the call stack window, in order to find out. So let's go and hit the third breakpoint, which is a bit more of a mystery. So we're now at the third breakpoint, and I can see that one of the tasks is in MOIC, that's what it was before. The other one is in MOTH, that's what that one was before. The third one in MOTH, again where it was, but the fourth one, remember this was in MOTH, now it's kind of morphed and starting life in D. So what happened there? Without examining the code, you cannot be deterministic about exactly what happened there. And this is one of the problems without having new support for examining your code. So let's store this mystery question and we'll come back to it in a minute. So now we're going to go and hit the 4th and final breakpoint. And at this point, I'm going to the threads that I went before, and I can see that that's not a task, and that's not the task either. So something has happened here. I'm only finding 2 of my tasks, and I can see one of them went from MOTH to FG, and the other one went from MOTH to EKG. So the 2 tasks merged and converged at some point, but maybe I have to do a couple of double takes since my call stacks are getting longer now to see where that has happened. And I had to play here, like I say, the game Hunt the Task in the threads window, which is not a good game to be playing. So with that, let's go and stop this and run this whole thing again. And now I'm going to show you how we're going to get rid of those pain points, if you like, with the new tool windows. So we hit the first breakpoint. Remember, this is where I had to go and identify the tasks in the threads window? Well, we actually have a tasks window now. So in the task window, I can see the IDs for the actual tasks. And if I wanted to map them onto the threads that were executing them, well, here is the thread ID over here for the thread that is assigned to them. And this isn't just a visual thing that you look at, you can also interact with it. So in the same way as before, I can double click and you can see that the other windows update. And as this is updating, if we go to the threads window, that has switched as well. So it's fully integrated into the IDE and it's showing me other information like the location and so on. Now, as I was double clicking and changing here, the call stack window was updating. But if I really want to go and see where all my tasks are, I don't have to double click and look at the call stack window. We have a new window. So if we go on the debug Windows menu, you can see this is how I launch my parallel tasks window, and we have another one, parallel stacks. So when I bring this up, let's see what this is telling me. It says 4 tasks, and I can go over here and hover and have a look at the IDs for those tasks. 4 tasks are all sharing the same method context and the same call path. They went from M to O. And when I hover over, the tooltip gives me the extra stack frame information for each one of those tasks. So no longer double clicking, in one single view, I can go and see where all my tasks are executed. So here you're seeing the value of these 2 windows on the first breakpoint. Let's go and hit the second breakpoint. Remember what happened there? 3 tasks went one way and 1 went the other. Well, now it's very obvious what has happened here. I can see it. There's the 4 of them. And then after O, 3 of them, the tasks 1, 2, 3, went to TH and 1 went to IC. So now you can see even more the value of the parallel stacks window in showing you exactly where your code is executing. And if this is what I was expecting, then the picture has confirmed it. If it wasn't, maybe I want to investigate where that diversion took place. So again, this is integrated and interactive. So I can go here and actually bring up the context menu, and I can switch to the particular stack frame of interest on the thread that I'm currently on, or even change threads altogether. So by doing that, you can see the code editor updated, the other windows updated, and the highlight has changed. So now I can see this is the current stack frame that I'm looking at, hence the green arrow. And down here you can see with the yellow arrow where the active stack frame of the current thread is. And over here with the other icon, you can see where the active stack frame of the non-current thread is. So all these concepts, these icons, and the concepts that I've just mentioned, they're already in the IDE. So we're just reusing them, but in a nicer way, if you like. So let's go and hit the third breakpoint, and remember that's the mystery one where we didn't know what happened. So as we go and hit this breakpoint, now there's no longer a mystery. Look here in the task window. It's quite obvious. We had the task running, and it just created a child. So you can see here the parent-child relationship, and you can see in the parent column the parent-child relationship as well. And that's the child that started life in D. That's why we're seeing this thread morphing into something else, because it's the same thread executing 2 tasks. One of them is waiting, so we reuse the thread to execute a different task over there. So parent-child relationship is a very important concept in task-based programming, and this tool exposes it in a nice way for you. Now, in addition to the parent-child view, there's many things you can do here. You can go and sort on the various columns. You can go and group if you want by the various columns. And you can see here I can collapse these groups. If I want, I can see statistics, and you're seeing the status column shows waiting and running. Well, if I had scheduled some tasks and those tasks had not executed yet, they would be scheduled. So then we would be showing you the actual scheduled tasks too, and you can see what kind of load you're putting on your engine. So the task window is very powerful in that regard. Well, let's go and hit the fourth and final breakpoint. And remember, this is where we were playing the hunt the task game, the threads window. Well, now with the task window, it's very clear. I only have 2 tasks. So obviously the remainder have completed. So we can see that these are the 2. And when we go and look at the stacks window, again, very clear. 2 are what we have, and 1 went one way, the other went the other. And because it's only 1, double clicking will switch it. And you can see again the green highlight telling you exactly where you are at any given moment in time. Also notice here, I'm actually having in bold the method that I've selected. And if I go and select a method which also appears on other call stack segments in the stacks window, it is also bold. So that helps you find all the different methods wherever they are. If you wanted to pivot on the method view, you can do exactly that. So you can come here and actually switch to method view, and now I can go and see that that is the method context that is being called by whoever and calls whoever itself. So the callers and callees are easily visible. If I switch to another method context, that will be even more obvious to look at. When I'm bored of this view, I can go back to the stack view, obviously. So before I go and end this little tour of these 2 windows, Other things for you to notice and play with when you get these bits in your hands. We have support for things like flagging, so I can go and flag tasks, and this would be if I have far too many tasks in there, this will help me concentrate on the ones I want. But in addition, I could go here and say, well, show me the flagged only tasks, and I can filter the amount of tasks that I can see on my stacks window if that gets too big for me to focus on. The other thing that you'll notice here is that in addition to the new programming model, the task-based programming model, we're also supporting traditional multi-threading. So notice here on the stacks window, we have the threads view, and here I can see the tasks that I had, but in a thread-centric view now, so there's more code here at the root, but also I can see my main thread, for example. So even if you're doing traditional multi-threading, you'll find this a huge improvement over the call stack window, which only supports one thread at a time. Now I could go on and show you things on our context menus, such as freezing all assigned threads but this, which will allow you to single step into a particular task. But I want to leave something to your imagination and for you to play with, so I'm going to call it a day there.
Great. Well, thanks a lot for taking the time to show us some of these cool features, Daniel. It's been an absolute pleasure. And until next time, we'll see you all miners later.
Thank you.